Question 6 is a bit special because this question gives us the measurement of one cell and then asking us for the actual size of another cell on the same image. From the question, we can see that magnification has been given, the image size has been given, and they are asking for the actual size of another cell. So based on this, we can conclude that this question is actually the questions that apply the magnification formula, and it is a type 2 question where image has been given. Just that we have to do the measurement in order to solve the questions. So first thing first, we should apply the magnification formula. But before that, you can see that there is measurement given for this P to Q. Yeah, there's a measurement given. Yeah, it's 2.6 mm. Yeah, 2.6 mm. So again, we should use our ruler to measure whether it is exactly 2.6 mm or not. So same thing again, I'm using my physical ruler to measure it on my screen or on the paper. And I find out that it is not exactly 2.6 mm. So when we find this, we find out that the image, yeah, the measurement given is actually not same as our own ruler. Then we have to find the measurement first. Okay, we have to find the actual measurement for this cell first. So we are going to use this 2.6 mm as the reference in order to find the image size for this erythrocyte first. Right, that is a red blood cell. Yeah, so because this is what the questions want. Yeah, the questions want the size of erythrocyte. So that's why, yeah, we will use the 2.6 mm of the neutrophil to find the image size of this erythrocyte first. So that should be our first step first. Yeah, so that only then we can later substitute the image size of this erythrocyte into the formula, into the magnification formula. So the first step is we need to find the image size first. We have to find the image size, find the image size of the erythrocyte first. So this is one extra step for us. So this is what we are going to do. Because both of these cells, they are on the same image. So that means that their ratio is actually fixed. The diameter, the image size of this erythrocyte and the image size of this neutrophil is actually fixed. So based on this, we can actually write down the ratio first. Okay, so now when we used our ruler to measure the neutrophil, yeah, so based on the ruler, yeah, okay, this is when you use your ruler to measure, okay, so that's ruler N, then we divide by the actual measurement that's given. Actual measurement that's given is 2.6 mm. Okay, then it will be equals to the, when we use the ruler, when you use our ruler, yeah, our ruler to measure the erythrocyte. So that will be ruler E. So when we use our ruler to measure the erythrocyte, and then divide by the image size, that is the image size that we want to find. What is the image size here? Okay, so based on that, so now we will make the measurement. So from my ruler, okay, so now let's say I use my own ruler to measure that, okay, let's say, yeah. So when I measure that, it is actually, yeah, 2.1 cm, you can see here. It's actually 2.1 cm, yeah. Okay, so it's not so accurate, but then for my physical ruler, yeah, from my physical ruler, it is 2.1 cm, yeah. So maybe I just enlarge it a bit. Okay, so let's say it's 2.1 cm from here. Yeah, it is from my actual physical ruler. Yeah, it's 2.1 cm. So that means that when I use my ruler to measure the neutral field, it is 2.1 cm. But to prevent the confusion, I don't put the cm, I will just put an R. Then divide by the measurement given is actually 2.6 mm. Yeah, that is the measurement given, yeah. So from here, you can see measurement given is 2.6 mm. So that's why we will write that down here, 2.6 mm. And then when I use my ruler to measure the electrocyte, so let's say now I measure the electrocyte. So I can see that it is 1.3 cm. Yeah, it's 1.3 cm. Yeah. So from my actual ruler, it is from my physical ruler, yeah, when I measure on my screen, it is actually 1.3 cm. Yeah. So that's why for electrocyte, when I measure is 1.3 cm, I don't put the cm to prevent the confusion. So I've just put 1.3 R. So the image size is what we want to find. So based on this, then we can do the calculation now. So I will be equals to 1.3 R times 2.6 mm divided by 2.1 R. Okay, so based on this, I will do the calculation. So it should be 1.3 times 2.6 divided by 2.1. So it should be 1.61. Yeah, 1.61 mm. So 1.61 mm. So that is the image size. So that will means that, so no, we don't need the ruler already. So that will means that based on the measurement given, P to Q is 2.6 mm. And we use this 2.6 mm as the reference. And now we can know that the image size for this electrocyte is actually 1.61 mm. So it is from here. The calculation is from here. So that means that the electrocyte is actually 1.61 mm. So this is what we get. Okay, so please remember this step is only needed. Yeah, this step is only needed when the measurement of the image, when you measure it using your physical ruler, is not the same like the measurement given in the questions. Okay, the measurement that you measure on the image with your physical ruler is not the same as the measurement given, then only then, yes, you will add on this step in order to find out, yeah, in order to find out what is the measurement here on the other cell. So now I know that this is the image size. I know the image size of the electrocyte already. Then next, I will just substitute that into the magnification formula so that I can get the actual size of this electrocyte. So that's why for step number 2, now once we get the image size, now we can find the actual size. So when you want to find the actual size, we will apply the formula, which is magnification equals to the image over the actual. Then what is the magnification? Okay, so we have to look into the questions. So the questions told us that this is a photomicrograph, yeah? So this is under the light microscope, and they directly tell you that this is under 200 magnification. Yeah, 200 times magnification. So that means that you don't have to times anything else already. So this is the total magnification already. So we will take 200 magnification. Image size is what we calculate just now. It is 1.61 mm. So that would be 1.61 mm divided by the actual size is what we want to find. Then we will do the calculation. So actual size, then 1.61 mm. Okay, so before I write that, we need to convert. The mm, we need to convert. Yeah, we need to convert to become the micrometer because the question asks us to state our answer in micrometer. Okay, so that's why now we need to convert the millimeter to become the micrometer. So to convert from millimeter to micrometer, you have to times 1000. Okay, so that's why it should be 1610 micrometer. Yeah, after we convert that from mm to become micron. Okay, so it is 1610. So I will convert 1610 micrometer. So divide by the 200. Okay, so done with this, then now we do the calculation. Actual size would be 1610 micron divided by 200. So we should get 8.05 micrometer. So that is the final answer.